just want you to realize that this here and this here are the same thing. That's the way we've been finding vectors, right? Find the terminal point minus the initial point. And that's what we have here. And this here is just another way of describing vector A in ordered pair form, right? Instead of as the name of the vector A. And so this statement right here is the same as this statement here. Okay? It's a little confusing because we're not used to looking at some number t that we don't know what it is. And we can't really picture what that looks like. But as we go through some examples here, I think you'll find it's not as confusing as it looks to begin with. Okay. Write a vector equation of the line passing through point 3, -9 and parallel to vector A, which is -1, 2. All right, so this is our point P1. Do we know what P2 is?
No.
So what would my, no. If it was 0, 0, I would know what it was, right? If I don't know what it is, I use X and Y. Okay? And so I want to use this model right here. Here's my equation. And so I'm going to say that X minus, I'm sorry, yeah, X minus 3 and Y minus a -9, right? 0.2 minus 0.1 is equal to what? You tell me the rest of this.
And
-1, 2. So if they ask us to write an equation of a vector equation of a line passing through a point, that's what they're looking for. Okay? Write a vector equation of a line passing through a point. So it looks just like that. All right? In parametric equations, the formula looks like this. I'll give you time to copy that, and then we'll go through the example. All right. The second one, excuse me. Parametric equations, a line passing through point P that's parallel to a vector A has the following parametric equations where X is equal to, and what we're doing is we're breaking it down. Think of it as two separate components, a component for X and a component for Y. That's how we get the parameters of parametric equations for X and Y. So X is going to be X1 plus T times A1, and Y is going to be Y1 plus T times A2. Okay? And so that's how we're going to find this. And that's very simple, straightforward when they give us any information. So they give me vector B, which is 3, -5, and they give me a point 4, 3 that the line passes through. Make a table and graph the line. So first, let's write the equation. So what's X going to be? 3 plus T 3, which we would normally write this way. Okay? And then what's Y going to equal?
-5 plus 4.
Oh, I'm sorry.
Wait, yeah, the 3.
No, I listened to you, but I shouldn't have. What's the X value? X1.
So 3.
What's X?
X1 would be, yeah.
X1 was the point. So what's X1? 4 plus T times A1, which is 3. So now if I rewrite that, I get 4 plus 3T. Okay? Now, what is Y going to equal?
3 minus 5t.
Okay. 3 minus 5T. Or T times 5 and then 3 minus 5T. So there's my two, there are my two equations. equations. Alright? Now we're going to use those equations to find x and y values. I don't know why I put a T up there, made it look like a power. But I'm going to make a table, and I'm just going to choose some T values of -1, 0, 1, 2. And we're treating T like it's another variable. And we're choosing the T value. So if I put -1 in, if I put -1 in here, what do I get x to be?
1.
4 plus 3 times -1 is 1. If I put T in here, -1 in here, what's y?
8.
Okay? Alright, now let's do that with 0. What is it? 4. And y? 3. And if I put 1 in, 7. And
-2.
if I put 2 in,
10. And -7.
okay. Did I lose anybody in finding those values? Some of you got it quick, and I listened to you and wrote down what you said, and we went kind of quick through there. Now we're going to plot these ordered pairs. 1, 8. And 4, 3. And 7, -2. And 10, -7. My recording symbols away. Something like that. And so my line looks like this. If I could graph well. Something like this. Close enough. We had actual grid, if I put the graph up there, then it would have worked a little better, but it looks like that. Okay? So to find our values for x and y, to graph it, we have to start with our table, and we have to plug in numbers for t. It's like the old t-chart where you chose numbers for x and solved for y. In this case, we choose numbers for t, then we use them in the x equation to find x, we use them in the y equation to find y. Okay? So our graph looks like that. Any questions on that example? Okay? I believe that's it. We just have a couple examples here from the book that we'll look at, and then you'll have the rest of the class to work and get help if you get stuck. Pause. In the first one, I guess I should read the directions now that I'm recording. The first one says, write the parametric equations of each line with a given equation. And so we want the parametric equation that's going to be x equals y equals, and what variable is in that equation? T. Okay, and so this is this simple. We're always going to say x is equal to t. Okay? We say x is equal to t. That's how we're going to start. And then y is going to equal what? If x is equal to t, what's y equal to? is equal to t, so it's 4t minus 5. That's right. Okay? I guess I also had 14 on here. I added later. We'll go back and do that one also. Those are my parametric equations. Yeah? So if they give us an equation, we start out by saying x equals t, and then we replace x with t. Solve for y, if it's not already solved for y. Okay? Now we're going to take this and go the other way. We have the parametric equation x equals negative 7 plus 1 half t, and x plus 7 equals 1 half t. Pause just for a second. I had written it, I had it written down, right? Probably after I worked it out, I went back and saved it, and I accidentally erased the wrong equation. These are my parametric equations right here in number 26. And you see what I did to begin with is I wanted to set this equal. I want to solve for t is what I want to do. And so I started this first one over here. I add 7 to both sides. Now what do I do to solve for t? Times everything by 2. So I get 2x plus 14 is equal to t. Do you agree with that? Then on the other one, what do I do with this to solve it equal to t? Divide both sides by 3, and so I get y over 3 is equal to t. Do you agree? Now, this is like solving a system. If I know that both values are equal to t, both quantities are equal to t, then I can set them equal to each other. And so 2x plus 14 is going to equal y over 3. And if I want this in this form, I would multiply both sides by 3. And so I would get, I'm just going to flip it around also. So y is equal to 6x plus 42. Okay? Y is equal to 6x plus 42. So this is my equation I got from using my parametric equations. So, to recap, in this example right here, we start out by saying x is equal to t, and then we substitute t in for x, and we get the y equation. In the other one, we want to take both of these parametric equations and solve them for t, so that we can set them equal to each other and write it as a single equation. Okay? All right. Any questions on that? Okay, I see in my notes I had also done number 14, and it's not on the board, so I didn't have it saved. But number 14, they give us point P, which is negative 610. They give us vector A, which is 3, 2. They want us to write a vector equation. And it looks like they're saying a parametric equation. And then the parametric equation. Yeah. So write a vector equation and then the parametric equation. So the vector equation we've already done from this. So go ahead and do that real quick. Michaela, did you get this one? Just the vector equation. Okay, good. So you said x minus a negative 6 is x plus 6, right? And then y what? Okay. And that's going to equal? I get to parametric equations?
Wait, do you take the parametric equation? Yeah, I did, I think.
There's actually a couple ways of looking at the parametric equations. There's the way they gave us, and then as I'm looking at this, I see another way also that I hadn't thought of before.
Can't you just take it out of the information they give you initially?
Yep. And so what do we get?
X equals -6, plus 3t, and then y equals 10 plus 2t.
That's correct. So what he's saying is 0.1 plus t times a1, and then 0.1 plus t times a2.
That might think.
Okay?
I see what you mean.
Now, another thing I'm looking at now, as I look at today, I don't know that I've ever looked at it this way before, but this is a scalar being multiplied by a vector, so we could multiply both of those, and so from the x we get x minus 6, I'm sorry,
X equals.
x plus 6 equals 3t, and if I subtract 6 from both sides, I get x equals -6 plus 3t. Same thing we had here. If I look at it this way, y minus 10 would equal 2t. Y minus 10 equals 2t. And so, if I add 10 to both sides, y is equal to 10 plus 2t. The same ones we get using the rule they gave us earlier. Okay? So a couple different ways of looking at there. If we want the parametric equations from the vector equation, if they gave me the vector equation, I could just set these equal and set these equal. And then solve for x and y. All right? I gave you your assignment, right? It's on the calendar, which is in 13 to 29 odds, right? This is Tuesday.